All right, chemistry, this is your first video lecture for chapter 4, section 3. We're talking about electron configurations. At the end of this section, you should be able to list the total number of electrons needed to fully occupy each main energy level. If you remember that term main energy level from previous sections, you'll remember that that is the principal quantum number represented by a lowercase n. I also want you to be able to state the Aufbau Principle, the Pauli Exclusion Principle, and Hunds Rule. And we'll cover this third objective next lecture. Let's get started with electron configurations. The arrangement of electrons in an atom is known as the atom's electron configuration. Because remember, these electrons are spaced out around the nucleus of an atom in very specific, predictable ways. It's not like you just throw a whole bunch of them in the bag and they look like a bunch of chicken livers. They are spaced out very specifically, very uniquely. Now, the lowest energy arrangement of the electrons for each element is called the element's ground state electron configuration. And when I say ground state, I'm meaning the same type of ground state we saw in a previous section, talking about the ground state of an electron, meaning its lowest energy level, also meaning it is closest to the nucleus. Here we're going to start off with the idea of relative energies of orbitals. We've talked about the idea of s orbitals, p orbitals, d orbitals, and f orbitals. What we haven't talked about is that there are more than one s orbital. There's more than one p orbital. There's more than one d orbital, and there's more than one f orbital. And each of these have respectively higher and higher energies. For example, there's the 1s down here at the bottom. There's the 2s, which is higher energy than the 1s. There's 3s, which according to this graph is not only higher in energy than the 2s and the 1s, it is also higher in energy than the 2p, because over here on the left, on the y-axis, we have energy. And anything that is higher up that axis is higher in energy. Now, there are rules governing electron configurations. There are 3 of them to be specific, and we're going to go over those right now. The first one is the Aufbau Principle. Aufbau is simply a German word that means building up. That's all it means. It's not the name of any particular scientist. It actually just means building up. So according to the building up principle, an electron occupies the lowest energy orbital that can receive it. All right, so the lowest energy orbital that is open that can take an electron will. You don't jump straight up to the 4f orbital if the 1s orbital is still open. The second rule is the Pauli Exclusion Principle. And according to the Pauli Exclusion Principle, no 2 electrons in the same atom can have the same set of those 4 quantum numbers. Remember, we have the principal quantum number, we have the angular momentum quantum number, we have the magnetic quantum number, and then we have the spin quantum number. No 2 electrons in the same atom can have the exact same value for all 4 of those. At least one of them is going to have to be different. The third rule is known as Hunds Rule. According to Hunds Rule, orbitals of equal energy, okay, so the 5 suborbitals in a d orbital, or the 7 suborbitals in an f orbital, right? So orbitals of equal energy are each occupied by 1 electron before an orbital is occupied by a second electron. Remember, each suborbital can be occupied by 2 electrons, but before you can get a second electron, all of the other suborbitals must have at least 1, or they must have 1. And all electrons in singly occupied orbitals must have the same spin state.
All right, when you're filling electron energy level diagrams like this one, you have to obey 3 different rules. They are the Pauli Exclusion Principle, the Aufbau Principle, and Hunds Rule. The Pauli Exclusion Principle says that no 2 electrons in an atom have the same 4 quantum numbers. The Aufbau Principle means fill from the bottom up. Orbitals of the lowest energy are filled first, from the bottom up. And Hunds Rule says that if you have multiple orbitals of the same energy, put one in each before they double up. In this case, P has 1, 2, 3 different orbitals. One goes in each one before you double it up. A common question you might find are, which of the 3 rules does this electron energy diagram violate? Well, here in the 1s we only have 1 electron. You're not allowed to fill upper orbitals until you've filled all the lower ones in a ground state atom. This violates the filling from the bottom up principle, or the Aufbau Principle. You can't do that. Let's see what we have here. Here, we've filled from the bottom up, so that's good. And we've even put one in each of the P's. But what I notice is that we have 2 electrons in the same orbital that are both spin up. That means N is the same, because N equals 1. L is the same. It's an s orbital, so L is 0. ML, when L is 0, can only be 0. And if they both have spin up, that means their MS's are the same too, both positive 1/2. Here we violated the fact that no 2 electrons can have the same 4 quantum numbers. They're both spin up in the same orbital. You can't do that. This violates the Pauli exclusion principle. It excludes you from doing this kind of crap. What does this violate? Well, you can probably guess it violates the Hunds Rule, because it's the only one I haven't done so far. But take a look. You need 1 in each of these P's before you double up. That's the key here. 1 and 2 here, 1 here is 0. No, spread them out. This violates Hunds Rule. You can't do that either. The question becomes, how do you even do this properly? Well, you'll notice each of these had 7 electrons. So I'm going to put 7 electrons in here properly, according to the 3 rules. Number 1, no 2 electrons need to have the same 4 quantum numbers. Number 2, fill it from the bottom up. Number 3, spread them out before you double them up. So, 1, 2, 3, 4, 5, 6, 7. Went from the bottom up. I made sure each of these had 1 in it before I started doubling up. And I made sure 1 was always up and 1 was down. Follow the rules and draw your electron orbital filling diagrams properly. Don't not spread them out. Don't have 2 spins the same in the same orbital. And don't not fill a lower orbital before you start cramming them in the top ones. Best of luck.
Alright guys, this is where we're going to leave off for today. We'll pick up the second half of this lecture next time we meet. I will see you next period.